Hi everyone. This is the second video in our series on market trends and drivers. You may recall that the first video was on demographic trends. This one is on health care and health conditions and the way in which they influence market conditions. So with that, let me try to bring up our video here. That's always a little challenge for me, and see if we can get going. Okay. Let me also make sure that we've got our recorder on. Yeah, we do. Okay, so I guess at this particular time when I'm making this video, we're in the middle of the coronavirus pandemic, and it's without a doubt the most important matter from a healthcare perspective on just about everybody's mind these days. The good news is that there is a major effort underway to create a virus, a vaccine for the virus, the coronavirus. There are well over 150 different virus candidates, and 7 of those are in the final stages of testing, and another 17 are getting close to being at that stage. So there's a lot of hope that before very long, we'll have a virus that will enable us to begin moving back toward more normal conditions. But in the meantime, the coronavirus has certainly created many different changes in market conditions and altered market conditions greatly. I'm often reminded of the way in which airlines and airline services have changed, and what that has done to the demand for aircraft produced by Boeing and Airbus, among others. But the change has been dramatic and financially devastating to aircraft manufacturers. So in any event, that's our current situation, but here's a sort of a scorecard for the 6 of the vaccines that are in their final phase 3 stages, or in the combination of phases 2 and 3. And one of the things you'll notice is that the first 2 are in China. And that's because the coronavirus broke out in China. So the laboratories in China have had longer to work on this problem than laboratories in other countries. In fact, that's one of the reasons for some tension between China and the US and European countries, is that the US and the Europeans have complained that China could have let us know about this problem a lot sooner so that we all could have gotten started working on it faster. But you can see that we now have some producers of vaccines in the western part of the world, and everything from Moderna down to Pfizer at the very bottom. And Pfizer is in phase 3, even though that candidate, or when this exhibit was prepared, it was a combination of phase 2 and 3. And we now have not on the screen, a new Russian candidate. And in fact, the Russians claim that they actually have a working vaccine. But time will tell. In any event, there's just a great deal of work being done to develop a vaccine. But those are not the only, or that is not the only driver of demand for goods and services that we need to pay attention to. One in particular that has been with us for a lot longer than the coronavirus has been the problem of obesity. In the first video, you may recall that in the past couple of years, life expectancy in the United States has actually declined a little bit. And one of the reasons that the analysts believe for that decline, contrary to the long-term rising trend in life expectancy, is in the United States the high proportion of obesity and overweight. And you can see that among the countries on this chart, the US is the highest of all, and indeed it's the highest in the world. Some over 40% of women and nearly 40% of men are overweight. And close behind is Mexico. And there are some reasons for Mexico's proximity to the US and the frequency of overweight and obesity. And it has to do with food preferences and availability of carbonated beverages and sweet tastes and so forth. But you can see that in China and India, those proportions are much smaller. And again, there's a reason for that. And again, it has to do with diet. Russia's an interesting situation because its proportion of women who are overweight certainly is not as high as in the United States or Mexico, but Russian women are overweight twice as often as men in Russia are. And I don't honestly know the reason for that, although there's a suggestion that it may have something to do with the way they spend their time working. Another concern that is driving the demand for healthcare and pharmaceuticals is diabetes. And once again, if I showed you a chart like the one I just showed you, the US as a proportion of its population would be very high in the incidence of diabetes. Now, the graph we're looking at takes into account total population and the rate at which diabetes is increasing. So in North America, including the US, Canada, and Mexico, we see an increase of some 37%. But in Africa, it looks like between now and 2035, the incidence is expected to double. And you can see the other growth rates in the left chart, showing expectations of increasing diabetes between now and 2035. It's a major health concern. Now, bearing in mind that countries such as China and India, in particular China and India, have much larger populations than the United States. China has a population of about 1.4 billion people, India about 1.3 billion, and growing faster than the Chinese population. Soon, if it hasn't already caught up with China's population, will do so. No surprise that we see more cases of diabetes in China. It's not due to a higher incidence, it's due simply to so many people living there. And with essentially the same size population as China, India's incidence of diabetes is substantially less. But what is also remarkable is that the number of cases in the United States relative to its population of only about 330 million people compared to 1,300 million or 1,400 million in India and China. The U.S. Proportionately has a higher incidence of diabetes than those countries do. And diabetes carries with it some very, very serious ailments besides diabetes itself. It can affect vision and a whole lot of other conditions that make the person with diabetes a lot less comfortable. It can even be mortal. So this is a serious problem and creates yet another demand for pharmaceuticals and healthcare and management of diets and food processing and so forth. The Center for Disease Control in the United States has published a list of the 10 most important U.S. healthcare issues. I almost did not put this slide in this video because some of the items on this list are not related to industry and marketing, and others just barely so. So HIV, for instance, is a very special kind of a problem. Alcohol-related problems are teen pregnancy. Those are certainly important issues, but from a marketing perspective, they won't attract as much of our attention as food safety or healthcare associated infections, heart disease, stroke, obesity, and diabetes, as I mentioned earlier, and the difficulties that occur with administering drugs and so forth. So, and certainly tobacco use. So here we do have, in those items, we do have some very significant issues from a marketing perspective. One of the things that is affecting the outlook for healthcare and medical care is technology. And one area of technology is that is particularly prominent these days is artificial intelligence, which can be used in detecting diseases even before symptoms appear, and doing diagnosis in one case to detect cancer, and of different kinds, such as lung cancer, and to do diagnostic work, to take laboratory findings and examination information and make sense of it better than a physician can sometimes, because so many variables are required. For instance, AI technology can read X-rays and CT scans sometimes and get a more accurate diagnosis than the physician can, and at a minimum provide assistance to deliver faster and more accurate diagnoses, providing support to the diagnostic physician. AI approaches also are being used to develop treatments and recommend methods of treatment. Yet another device that is being used are surgical robots, and I think later on in this video we'll talk about one particular kind of surgical robot that I'm familiar with called the Da Vinci that really can do surgery more accurately and with less harm to the body than a human surgeon can. And as time passes, I think we'll probably see a great deal more use of surgical robots. And then finally, aging and aging research is being supported by artificial intelligence to identify opportunities to increase life extension. For instance, by boosting the immune system. As we get older, our immune systems wear down, and so one of the ways in which artificial intelligence is has supported the treatment of older folks is by identifying opportunities to boost the immune system. So here are some examples that illustrate what I'm talking about. You've probably heard of IBM's big computer, Watson, this great big computer is being used to optimize the diagnosis of disease and make decisions with regard to treatment. A couple of devices produced by the German company Siemens are interesting too. One of this, the AI RAD, can read chest CT images, perform measurements, prepare medical reports in order to identify and diagnose what it is that the X-ray or the CT scan sees. Another Siemens system is called AI Pathway Companion, and it gathers a lot of information about the patient, facilitates the diagnosis, and then spells out the therapeutic approach. The question then becomes, what do we do with this very modern, new approach to medical care and medical treatment? And what markets are being created? Certainly as a result of our enhanced ability to create vaccines, what kind of changes will occur in society and in our lives as a result of the coronavirus and our recovery from it when we go back to something like normal, but not the same normal that existed before the COVID occurred. Among other things, I think that we'll find out that there are a lot faster, more powerful ways that we can develop vaccines. And this will boost medical technology. already has. And as a result of the kinds of devices that I just mentioned, disease detection and prevention should be enhanced. Life expectancy, therefore, should be enhanced. I've put both favorable and unfavorable because, as we've seen, there are some trends in lifestyle, such as obesity and diabetes, and other ailments, not the least of which are different types of cancer, and heart disease. And those, of course, present very serious risks. And we're hoping that medical technology will create new opportunities and thereby new markets, new opportunities for the healthcare industry and the biotechnology industry. And the pharmaceutical industry, of course, where new pharmaceuticals are developed. In the case of today's circumstances, not just vaccines, but drugs to treat people who have contracted the coronavirus, and for that matter, other ailments. So whether we're talking about medical instruments, implements, robotics for surgery, software and computer systems for diagnosing, great advances are being made. Some folks believe that the age that we are in is essentially the age of medical technology. As we mentioned in the first video in this series, life expectancy is increasing as a result of what's happening in the healthcare technology industries. So it's what we know now and are able to do with healthcare, with genomics, with artificial intelligence in diagnostic systems, that these things are possible. An interesting question is just how does this affect the primary healthcare services provider, the family doctor, if you will. I'm certainly not an expert in that field, but what I seem to gather is that not as much progress has been made in the doctor's office has been made in the hospital. That we are in a trend of greater specialization, where ailments that were looked at by a family doctor today are looked at by a specialist who deals with a very small portion of healthcare. So the question then is, what changes take place in the office and the clinic of the family physician? Another, at a completely different level, question has to do with the food and beverage industry. Once again, back to obesity and diabetes. One of the reasons that obesity and diabetes seem to be growing is the prevalence of foods and beverages that are sweet. For instance, carbonated beverages and sweet tasting foods and beverages that kids have early in life, and they develop a taste for sweet things. So even if the beverage is sugar-free, if it's sweet, the kid gets a habit for wanting sweet tasting foods and beverages, and that starts them down the road toward obesity and diabetes. So all of these are trends that are going to have a great deal of impact on markets and drivers of new market conditions in the future. Well, let's move on and see if we can talk a little bit about automation. We've talked about artificial intelligence. Maybe we can talk a bit about how automation will influence business conditions of the future. I mentioned earlier robots. Another way of looking at and thinking about robots is that they are being used with increasing frequency in industry. So if you've seen videos of automobile plants, you may notice that robots come in and do a great deal of the welding and moving of material inside the auto plant. And a study by the NBEI demonstrated that robotics have had an effect on employment and wages to the extent that more jobs have been lost than created. This has also had an effect on wages. So industrial robots enable us to do much more accurate work, much more work without quality failures than is possible when humans do that work. But by the same token, then what are the humans that are no longer doing that work? What do they do to earn a living? They have to do it somewhere else. Another rather interesting trend in automation is the cobot, the collaborative robot. At the end of this video, I'll provide you with a list of some other videos that you can look at to see how, and papers that demonstrate how robots now are able to sit side by side with people and work together jointly, collaboratively, so that things can get done faster and more accurately. The robot doesn't look like what you might be thinking of in the form of with a head and hands and legs. It may just be an arm that moves back and forth, but it's doing it right next to a human who's doing things as well. And together they can work better, faster, more accurately than the human can all by himself or herself. This is occurring in offices and laboratories as well as industrial factories. And so, as the slide says, workers are going to have to get used to AI tools as co-workers. You see a little footnote there to indicate who drew that conclusion. Finally, the question of just what the benefits from an employment perspective might be from automation. In the past, it's been pretty well believed that with automation, with the use of computers and the like, new industries were developed, economies were grown, and so although people were replaced in some parts of the economy, there was new demand for people to work in more interesting jobs in other industries. But as you can see in that top bullet, the NBER has now cast some question on that proposition. And yet there's no doubt that with automation and robotics, the economy will be able to grow faster. And if the economy grows faster, the proposition is so will employment opportunities. So we've got two sides of this issue. But that first bullet where we see robotics and automation replacing labor, that does create some significant economic issues for the future. Another type of system is what we call decision support systems. You may recall when we talked about healthcare and automation in the hospital, where artificial intelligence systems were able to support diagnostics and treatment recommend treatment procedures. And decision-making is supported by automation in more than just hospitals. It's supported throughout industry. By 2025, automation will have augmented perhaps 28% of the decision-making tasks in industry. Now, one problem with that is that although we can build the models to do that work, the data that goes into them, either to create the model in the first place or to apply it, becomes a pivotal issue. We need good data to make good decisions, even if we have good models. And the good news is that here again, we have the support of artificial intelligence and decision support systems in the form of predictive analytics that will enable managers to make sense of all these data that we get regarding economic trends, market conditions, shifting demographics, and so forth, and to pull those together in the form of forecasts and diagnoses of accurate patterns regarding what's really going on. Sometimes conditions are so complex and changing so quickly that it's very difficult for managers to make sense of it all. But with these systems, we sometimes can do that when we would not otherwise be able to. Now, from a different perspective, a very well-respected firm, PricewaterhouseCoopers, a well-known accounting firm, but also does management consulting, took a look at 200,000 jobs in 29 countries, and they came out with a much more subdued finding that only about 3% of jobs were in the at present at risk of automation. Frankly, that doesn't square with the NBER research that we saw earlier. But PwC went on and concluded that the probability of automation substituting for human labor will rise to about 20% in the late 2020s, this decade, and that by the mid-2030s, only 5 years later, 30% of jobs could be replaced by automation. And if workers do not have much in the way of training or education, their risk could be as much as 44%. So the PricewaterhouseCoopers findings go from very subdued to almost dramatic. Suffice it to say that automation and artificial intelligence and robotics has beneficial effects and some effects that could be very problematic. So here are a few illustrations. One is AlphaFold, a system developed, a neural network by Google. And what's remarkable about AlphaFold is that it can predict the shape of protein structures, and that if and when this technique gets perfected, it's going to enable us to move a lot faster in developing new drugs and designing new proteins to fight disease. Really remarkable. Another example, natural language processing. It's possible for you to use Google now to look at a document in a foreign language and ask Google to translate it for you. And you'll usually get a pretty good result. Maybe not perfect, but pretty good. Imagine doing that with spoken language and very sophisticated language. And in fact, there is a field of artificial intelligence, natural language processing that deals with that problem. And indeed, a system has been developed which is so powerful that it was not released to the public. Presumably, it has some national security ramifications in its ability to translate foreign languages as they're being spoken or written or coming across electronic devices. And so eventually, these systems will enable you and me to communicate with people who are speaking in other languages, whether it's verbal or writing or across a terminal, and to communicate and not have to be impaired by differences in among other things, the language we speak. I mentioned surgical robots when we were in the last portion of this video. And one that I am familiar with it's called the Da Vinci, and it virtually hundreds of thousands of surgeries have now been done with this surgical robot. And to the extent that surgical robots can be used, the surgeon sits at a desk and manipulates devices that for him are reasonably precise. But if those same kinds of movements occurred inside somebody's body, they'd be very damaging. But the surgical robot can reduce the degree of movement to very precise levels, so that very precise movements and manipulations can be made within the surgical space. So that the surgery itself, you don't have to necessarily open somebody up. You can simply poke a hole in the side of the person and go in that way, and then work in a very restricted space so that the person, the patient, recovers from the surgery much faster. Much of this is being done and more will be done. And I happen to be familiar with some of these new techniques, and it's just amazing. Another kind of robotic device is the self-driving vehicle. And self-driving vehicles are robots, but they look like a cart or a truck. So it could be a cart within a warehouse carrying products from the location where parts are delivered to a factory to their designated location, in the warehouse where they're stored before they get used. It may be that these carts are used to take those parts to the assembly line. It may be that these devices are used to carry the finished product back to the warehouse or to the department that puts them in packages and so forth. Another type of self-guided vehicle is a truck in a mining or construction location. These trucks are today largely driven by human workers. And the problem is that humans sometimes make mistakes with these great big trucks, and the results can be tragic. Again, one of the firms that I worked with as a consultant made great big, huge construction equipment vehicles with forklifts and other devices, but they were very, very large vehicles. So an operator would drive the vehicle up to where a very heavy load, for instance, steel that had just been produced, a lot of steel, would be put onto the forklift. And then the driver would pick it up and drive toward the designation for that steel. And it might be a truck, it might be a freight car, it might be the load, the crane that's going to pick it up and put it onto a ship. Now, that's a pretty straightforward process. However, if the operator makes a mistake and happens to drive down a hill, even if it's a slight hill, when he's got this heavy load on the front, what's going to happen to that vehicle? It's going to tip over. And not only will the load be lost, the driver may be lost too. And so if you have a self-guided vehicle, a robot vehicle that has the artificial intelligence in it to avoid going down a grade, you're not going to have accidents like that. Similarly, in a factory, if a driver is driving a vehicle that's carrying products through the factory, he can possibly not be looking when somebody's walking in front and hit that person, who might happen to make a mistake and just simply have an accident and drive his forklift truck into something that he shouldn't drive it into. That won't happen with a self-guided vehicle that has artificial intelligence. So for all of these reasons, self-driving and off-road vehicles are in the future. And probably the first self-driving vehicles that we have won't be cars, because that's a little dangerous, but trucks that carry cargo in designated lanes can be self-driving and operated by artificial intelligence. Finally, the final example that I would offer you is Kiva Systems. It used to be a producer of devices that carry products through warehouses and factories, and was its customers included Staples, Walgreens, and Gap. But in 2012, Amazon bought it because Amazon is building more warehouses, more processing centers, and needed what Kiva Systems could produce to provide for material to move between packing stations, to be put onto conveyor belts and picked off of conveyor belts and so forth. Now, I'm sure that Kiva continues to serve its old customers, but its most important customer, its #1 priority, is to make those Amazon fulfillment centers work the way they're supposed to. Here's my final example. It's called Kamanika. Kamanika is an encyclopedia of organic chemical reactions, presumably all of them, but all known organic chemical reactions are included in this computer encyclopedia, which was developed by a professor at Northwestern University. And with this system, with this artificial intelligence system, it's now possible to identify possible combinations of elements in order to make new chemicals or new drugs. And in some cases, drugs are produced by series of chemical reactions. You have to produce, you just don't throw a bunch of ingredients into a device, mix them up and get a pill. Instead, you may have to produce some compounds from raw materials and then take those compounds after they have been purified and mix them together in several stages before you eventually get the material that makes the pill. However, with this device, it was discovered that it may be possible, that it was possible, in order to combine elements in just the right way, so that instead of going through several stages, you could actually produce the final compound in one reaction. It's called the one-pot solution, and it resulted in the ability of a drug manufacturer to take a manufacturing of a drug that took 3 stages. They could then do it in 1 stage, and of course, that was a lot less costly. So the Kamanika system is a remarkable way of taking known information about the atomic nature of chemical reactions and putting them into algorithms that can then be used to produce even other reactions and other compounds. In the article that you see on the screen, it's pointed out that human chemists, when they do work in the laboratory, they write things down, you know, or type them into their own computers. But that's not the same as putting them into an automated system where that information is kept and manipulated and used perpetually going forward. But once you can do it inside these systems like Kamanika, that information is never lost. And so progress moves further, faster. So what conclusions can we draw? First of all, robots are in fact replacing human workers in factories and warehouses. By the mid-2030s, 30% of industrial jobs could be replaced by robots and automation, and perhaps even more. So what do we do about that? How do we deal with that problem socially? It may be that unemployment increases to the extent that new employment is not found in functions that are now performed by automation. And automation is not occurring just in the factory. It's occurring in the office, and so we have collaborative robots or cobots. And we also have these decision support systems that are making managerial work more productive, as well as faster. And that's all an advantage. Corporations who have these systems, countries that develop them, are likely to enjoy the advantages of progress faster and to a greater extent than companies and countries that don't develop them. And so robots and artificial intelligence will greatly enhance productivity of technological industries such as chemicals with Kamanika, pharmaceuticals, healthcare, surgery, as we've seen with robots, and entirely new materials and compounds from systems like Kamatika will be developed. That creates great marketing opportunities to solve problems. And the purpose of these videos, of course, is to identify where new markets are occurring or where market conditions are changing. Intellectual work, diagnosis, translation of language, making decision with decision support systems by amalgamating and rationalizing large volumes of complex information. All of that is going to be enhanced. That's going to change the nature of managerial and technological work and the demand for altogether new skills. And it may be that we saw, as we saw in the first video, that as population growth rates decelerate and as the population of some countries actually declines, maybe that'll be for the better, because if population isn't growing as fast, then the need for employment won't be growing as fast. Nevertheless, we'll still have the question of how we generate the equivalent of employment taxes to provide for Social Security. So just because we've got lower population and thereby moderating unemployment, that isn't going to solve all of our social problems from the standpoint of welfare. So in any event, I hope that this video has given you a little bit of insight into what the possibilities are with regard to healthcare, the healthcare systems, artificial intelligence, robotics, and automation in healthcare, in industrial factories, and in offices. We live in a time of very rapid change, don't we? And so with that, I'm going to try to close this video if I can. I always have a little difficulty with this system because I never know when I have it turned on and turned off. But I'll hope that I'm going to be able to turn it off right now. Goodbye.